Let's get into it. What you're about to hear is too explosive for comfort. The universe exploded out of nothing. Literally, nothing. And that is the least strange thing about how it began. Number 10. For most of human history, the universe had no beginning. Isaac Newton looked up at the stars in 1687 and saw order. The same laws that pulled an apple to the ground pulled the moon around the earth. And the universe, he concluded, must be like a great clock, ticking forever, with no beginning and no end. It was a beautiful idea. It was also impossible. Think of it this way. If there were truly infinite stars in every direction, the entire sky, every single point of it, would glow. Day and night, the sky should be as bright as the surface of the sun. But it isn't. It is dark. And that darkness needs an explanation. The universe Newton described cannot exist. And that quiet darkness above you is the first crack in everything. Number 9. Einstein tried to fix the problem. He found a bigger one. In 1915, Einstein gave us a new picture of gravity. Space and time are not a stage on which the universe performs, they are part of the performance. Massive objects bend the fabric of space itself, and what we call gravity is simply the curve they leave behind. The Earth does not fall toward the Sun. It follows the shape the Sun has carved into space. 4 years later, during a solar eclipse, astronomers watched starlight bend around the Sun exactly as Einstein had predicted. The world declared him a genius. But his own equations told him something he did not want to hear. The universe could not stand still. It had to be either expanding outward or collapsing inward. Einstein added a fudge factor to his equations just to make the universe sit still. He would later call it his greatest mistake. He was trying to hold still a universe that was already in motion. Number 8. A woman no one remembers changed the size of the universe. Henrietta Swan Leavitt was one of a group of poorly paid female astronomers hired to catalog stars. She noticed that certain pulsing stars beat in a rhythm that revealed how bright they truly were. Like a lighthouse, the faster it flashes, the brighter it truly is. Compare that to how faint it appears, and you know the distance. Edwin Hubble used her discovery to measure the distance to a faint smudge called the Andromeda Nebula. His answer? Nearly 1,000,000 light-years away, far beyond our galaxy. That smudge was not a cloud. It was an entire galaxy, sitting in the dark, unrecognized for all of human history. In that single measurement, the known universe grew by a factor of 1,000,000. Then Hubble found that nearly every galaxy was moving away from us. The farther away, the faster it fled. One woman, one discovery, one measurement, and the universe was suddenly 1,000,000 times larger than anyone had imagined. It had been hiding in plain sight. Number 7. A Catholic priest found the beginning of time. Georges Lemaitre was both a physicist and a Catholic priest. Using Einstein's equations, he traced the expansion of the universe backward, like rewinding a film, past galaxies, past stars, past all structure, until everything converged on a single point of unimaginable heat and density. He called it the primeval atom. A British astronomer named Fred Hoyle hated the idea. On his radio program, he mocked it, calling it dismissively the Big Bang. The name stuck. Because space and time are woven together, the beginning of space was also the beginning of time. There was no moment before the Big Bang. Not because something prevented it, but because the word before had no meaning yet. A day without a yesterday. 7 down. What you've heard so far is science slowly finding its footing, century by century, person by person, mistake by mistake. What comes next is where the ground disappears entirely. Number 6. The oldest light in the universe is surrounding you right now. In 1965, two engineers at Bell Labs couldn't explain a persistent hiss in their antenna. They cleaned it, removed pigeons nesting inside. The hiss remained. What they had found was the oldest light in the universe. After the Big Bang, the entire cosmos was a hot, glowing soup, too dense for light to move through. For 380,000 years, light was trapped. Then the universe cooled just enough for atoms to form, and the light flooded free in every direction. As the universe expanded over 13 billion years, that ancient light was stretched and cooled to almost nothing, just barely above the coldest temperature the universe allows. It washes over the Earth from every direction, right now. Two engineers were trying to fix a hiss. What they were actually hearing was the echo of the first moment the universe became visible. It is passing through you as you listen to this. Number 5. The universe should not look the way it does. Measure the temperature of deep space in one direction. Then turn around and measure the other. Almost identical, despite the fact that those two regions have never been in contact. Light from one side has never reached the other. So how do they know to be the same temperature? This is the horizon problem. Then there is the shape of space itself. Measure the geometry of the universe and you find it almost perfectly flat. But this flatness is unstable, like a pencil balanced on its tip. Any tiny imperfection would have sent everything off course. Either the cosmos tears itself apart or collapses before a single star can form. The universe is too perfect, too smooth, too flat. Something ironed it out before we existed to ask why. Number 4. The answer was hiding in empty space. In 1979, a young American physicist named Alan Guth couldn't sleep. He had been wrestling with the same two problems for months: why the universe looked so impossibly smooth, and why space was so perfectly flat. That night, he sat down and calculated what would happen if the very early universe had briefly behaved like supercooled water, held just below freezing, waiting to tip. He ran the numbers. Then he ran them again. In a fraction of a second, the universe would expand by more than 100 trillion times. Not the matter inside it, space itself. It would smooth out every temperature difference. It would flatten every imperfection, all in less time than it takes light to cross a single atom. He called it inflation. It solved the horizon problem. It solved the flatness problem. It explained why space looks the way it does in every direction we have ever looked. He wrote in his notebook that night, "Spectacular realization." One sleepless physicist had found the iron that smoothed the universe flat. Number 3. The bang did not begin with matter. It began with nothing. The universe does not begin with a ball of matter that explodes. It begins with empty space. But empty space, it turns out, is never truly empty. Even in a perfect vacuum, invisible fields fill every point, seething, flickering, never still. Particles pop in and out of existence for fractions of a second before vanishing. The vacuum itself hums with energy. Inflation forces empty space to expand at impossible speed. A region smaller than a grain of sand becomes larger than everything we can see, in less time than light can cross a single atom. At this point, there is still no matter, no light, nothing but expanding empty space. Then, inflation ends, and all the energy of that field converts immediately into matter and light. Every star, every galaxy, every atom in your body, forged from the energy of empty space in a moment that lasted less than a heartbeat. What banged was nothing, and from that nothing, everything followed. Number 2. Our universe may be one of infinitely many. Inflation does not end everywhere at once. It ends in patches, like ice forming on a lake, not all at the same moment. Each patch where inflation ends produces its own Big Bang, its own universe, its own space and time. While one patch becomes our universe, the space around it keeps inflating, spawning more patches, more universes without end. This is the multiverse, not a fringe theory, the direct mathematical consequence of the same idea that solved the horizon problem, the flatness problem, the stability of space itself. Our Big Bang was one of an endless series, each universe sealed off, each with potentially different laws, different constants, different everything. We cannot see them, we cannot reach them. But the same equations that explain why the ancient light surrounds you say we are not the only ones. Number 1. The most honest thing science has said about the Big Bang. Alan Guth, the physicist who gave us inflation, who solved 3 of the deepest puzzles in cosmology, said this: "The Big Bang theory was never actually a theory of the bang. It says nothing about what banged, why it banged, or what happened before it banged. The expanding universe is real. The ancient light surrounding you is real. The hot, dense beginning is real. None of that is in question. But what caused it? What came before? Whether time itself had a beginning, these remain open. Not because we lack cleverness, but because the universe, at its very origin, lies beyond the reach of every instrument we have ever built. We are made of the aftermath. We live inside the echo, and we are only just beginning to hear what it is trying to tell us."